Okay, so that's life now. So we're going to have a look at trigonometric graphs. Sine, cosine, and tangent. Today we're going to probably start with sine and maybe cosine. I don't know what we'll start with from somewhere. Okay, so we're going to be sketching them. Okay, so we're going to be sketching them. And you know what sketching means? It doesn't mean that you're going to be drawing it with some, say maybe giving a table, an XY table, and asked to draw it based on the table. No, you're going to be thinking about some key points, okay? Some key points, and using those key points about the graph to make a sketch of the graph, okay? So the first key point is the period. And the period is how many degrees before it repeats itself again, okay? Because it's like cycles, like a wave, okay? How many periods, how many degrees before it repeats itself again? And the other thing that we are going to have a look at is the amplitude, okay? The amplitude is how far away from the x-axis it is in the positive and the negative direction, okay? Positive and negative direction. The frequency, you also have the frequency, which is just like how many cycles, okay? Frequency is just how many cycles. So generally, let me get my notes here. So generally, if you have y is equal to a sine bx, yeah, then a would be the amplitude and b would be the period, okay? A would be the amplitude, how stretched it is, yeah? How stretched it is up and down. And B would be the period, the period. The period is calculating the degrees. How many degrees before it turns again? How many degrees before it turns again? Yeah? So that would be the period. So guys, if I have y is equal to 3 sine 2x, write in the charts for me, what is the amplitude of this function? What is the amplitude of that function? I'm waiting, guys. Come on, in the chat, please. Three. Thank you, Abdullah Aloud, the only person who wrote something. And what is the period? 2. Thank you. So you know that, okay? Now, both sine and cosine have a period of 360 degrees, okay? I'm going to type that down for you so that you remember it. Both sine and cosine (360 degrees), okay? And in radians, we will call that 2 pi, okay? Make sure that you are writing everything down that I'm saying. 2 pi, okay? Because 1 pi is equal to 180 degrees. 1 pi is equal to 180 degrees, yeah? So 360 degrees is 2 pi in radians. We'll have a look at how to use them in numbers and in radians. Okay, I'll give you some time to catch up with everything that is on my board. Write them down and think about them, okay? Write them down and think about them. Okay. So let's have a look at the sine function then. You know what the period is, you know what the amplitude is. I told you what the general formula is. If you have y is equal to a sine bx, then the amplitude is a and the period is b. Okay, both sine and cosine have a period of 360 degrees. Yeah, 360 degrees, 2 pi for sine and cos. Okay, 360 degrees, 2 pi for sine and cos. Let me mark you in our ring. And you need to take a screenshot of the screen because, oh, where is it now? For those of you who don't know how the register works, it doesn't have anything to do with me, okay? So don't come telling me that I marked you absent when I didn't even touch the register, please, okay? I've told you before that if there's nobody in class, it puts everybody into absence. If it is 10 o'clock, your lesson is scheduled on the register. If the teacher is not there and you are not there, everybody is not there, all of you will be absent. It will put it automatically in absence. So don't come asking me why I marked you absent when I was not even there myself. You guys, you are so funny. You are missing your register something. Okay. All right. So let's have a look at the sine graph, okay? That's okay. I hope you've taken a screenshot of the of everything that we've done so far in. Have you taken a screenshot? Okay. I've marked you in, all right? Okay, let me leave this one because that's important. Amplitude and the period. Yeah. Okay, let's have a look at sine theta. And you guys are going to sketch this and send to me because you need to know how to sketch all of them. All right. Now, we don't need graph paper for this. We are just doing sketch. So you need to use plain sheet of paper. All right. Ruler, pencil. That's all you need. So if we have y is equal to sine x, yeah, then the sine graph looks like a hill. It starts from the bottom and goes up, comes back down, yeah, just like that. So I'm going to make a sketch of that for you now, okay? So I'm going to make a sketch of that for you now so that you see how it works, how you start to think about it. Okay, I already told you that the sine graph, the sine and cosine function both have a period of 2 pi. So I'm going to say, let's draw y is equal to sine x for 0 is less than or equal to x is less than or equal to 360 degrees. So I'm going to draw my x-axis. Then I'm going to draw my y-axis. Let's just make this a little bit longer. And make this a little bit longer. I move this way. And this is gonna be my 0 right here. This is going to be my x-axis or theta, and this is going to be my y-axis. Yeah. So here the amplitude is 1 and the period is 1 because there's nothing written there. You know that it's 1 and 1 here. Okay, so if it is 1 and 1, to complete a full cycle to make that shape of the hill, okay, or an upside down S, yeah, to make that upside down S, I'm going to start from 0. This is going to be 1 because the amplitude is 1. It's going to come down to -1 because the amplitude is 1, okay? And I'm going to have my markers, okay? Divide that into quarter because it's a bit like a wheel, yeah? When you start from 0, it does 90 degrees, it does 180 degrees, it does 270 degrees, and it does the full circle, yeah? So that's how it goes. So 90 degrees takes it from 0 up to, let me just mark it there. This is 90, this is 180, this is 270, and this is 360, yeah? So think of it as a full circle. Let me rub this off and draw it properly for you so that you can see what's happening. Yeah. Think of it as a full circle and you're going up in quarters. Yeah. So this is going to be 0 to 90. To 207, 180. 270 and back to 360. So it goes up and does the first quarter for 90. Yeah. Cuts down 180 and does another quarter for 270 and back to 360. Okay. That's how it should be in your graph. That's how it should be in your graph. And this is pi, and this is 2 pi. Okay, if you're using radians. Okay, this is pi, 1 pi, and 2 pi. Oh, you can see 1 pi over 2. Yeah. 2 pi over 2. You can say 1 pi over 2. Yeah, people do that. 1 pi over 2. 2 pi over 2. 3 pi over 2. And 4 pi over 2. It's just going to give you 2 pi. It's just going to give you 1 pi. Okay, this is the radians. And this is degrees. You need to know how to do both of them, all right? Okay. First thing I want you to do, make a sketch of that and send it to me fast. With your pencil, you don't need graph paper. All you need is a white sheet of paper like my screen. Okay, I want your graph to be neater than mine because you're working at home, you got your pencil and everything. You got to have your graph. Yeah, you got your pencil and your rubber. Yeah, so it's hitting here. Okay, so I need your graph to be neater than mine. Okay, guys, I need you to sketch that and send it to me straight away. Now, think of it as going in quarters. Yeah, so this is the first quarter is 90 degrees. Next one is 180 degrees. The next quarter is bringing it down for 270. And the last one is 360. It's like an upside down S, okay? Think of it as an S that is flipped, okay? A flipped S. Or think of it as a heel that goes down and back up. I want you to sketch that and send it to me in your books. Let me put this computer on so that I will know when your messages come in. Ah. So I'm going to let me come into the stream with this computer so that I can share with you guys. Where is my let's have a look. Gmail. Start messages. Me. Lunch meeting. Turn this out video. Okay, so there we are. I think I'm in now. Okay, I think that's all right now. It's working. I can share my screen with you guys on this computer. So let me make that computer the host so that I can share your screen. Let's have a look. Participants. More. Make host. Yes. Okay. I can work from here now. Yes. Yep. Here. So Ray, this is yours. Let's see. So you need to write on there, y is equal to sine x, okay, or sine theta. If it's sine theta, then your here would be theta. Okay, so this is y is equal to sine x. All right, and I hope you understand how the radians work. So that looks fine to me, yeah, because it's just a sketch. We're not trying to make a perfect graph. We're just trying to use the information that we have to make a sketch. Okay. Anybody else sent their work to me? Quickly, guys, I need to see your graph. I need to know whether you're doing it good, all right? Okay. Okay, so make myself the host here again. Oh. 6 seconds. Yes. Okay. So let's go back to what we were doing. So guys, now you know how to draw the SIne graph. I only got one person to send me their graph. I only got one person who sent me their graph. Oh, you just took a screenshot. Okay. If I don't see your graphs, you will not know what to do when I start to transform them, because I'm going to do a transformation of these graphs. Yeah. Or I'm going to change some of the information on there, and then so that you can see how the graph is when it's looking different. Okay, when it's changed, you can see what it looks like when it's changed. Now, this is y is equal to sine x. For 0, it's less than or equal to x is less than or equal to 360 degrees. Yeah. Now, we can change that information. Yeah, we can say, how about we sketch the graph of y is equal to 2 sine x. Yeah, y is equal to 2 sine x would be very similar to what we've just drawn. But the only thing that will change is the what? the amplitude, okay? So let's see, y is equal to 2 sine x, yeah? On the same page that you drew the first one for me, make sure that you draw the second one on the same page for me, okay? So the only thing that will change is instead of having 1 and 2, you would have negative, you have 2. Hello? Golden Delicious. It's towards the end, the green ones. It's green. Yeah, green apples. Pomegranate is just when you come off the when you see the apples, then just turn right, okay? Come right into the main street. Yeah. Thank you. All right. So now to draw y is equal to 2 sine x, or yeah, 2 sine x, you would have up here 2. Okay, let me use red so that it's all the same, or use a different color, not black. So you would have 2 here, and on the bottom you would have negative 2. Yeah, let me extend this a little bit more. Yeah, and on the bottom you would have negative 2. So y is equal to 2 sine x. It's going to be the same graph, but it's just going to be a little bit stretched. Okay, it's still doing the first quarter at 90 degrees, another quarter, which is cutting the x-axis at 180 degrees. But instead of it being on 1, instead of it stretching to 1, it's stretching up to 2. Yeah, and then it's stretching right down to negative 2. Yeah, for 270 degrees, and coming back up to 360 degrees. Yeah, for 0. So that's y is equal to 2 sine x. Yeah, so on top of the graph that you have just drawn for me, sketch the second graph. Sketch y is equal to 2 sine x. And you write on here, y is equal to 2 sine x. And then y is equal to sine x. Okay? So of course, you know what y is equal to 3 sine x would be, y is equal to 4 sine x, and all of that. You'll see them, you know how they behave. Yeah, when you change the amplitude, it's going to be a bit more stretched when you change the amplitude. Yeah, the waves will get longer. It will be a bit more stretched. Yeah. Okay. Yeah, we'll have a look at that now. We'll have a look at that one now, okay? So we've been talking about the amplitude. We've been talking about the amplitude. So let's have a look at what happens when we change the period. Yeah, what happens when we change the period? Let me see. But before we get to that, let's see what happens when we change the sign. Yeah, what happens when we change the sign? Okay, before we get to that. So we have y is equal to sine x. I'm going to rub this one up, off, or let me leave it. What about y is equal to negative 2 sine x? What do you think it will look like? Any ideas? Y is equal to negative 2 sine x.
This will be from down and then up.
Yes, exactly. Well done. Yeah. So negative 2 sine x is going to come down for 90 and another up and up for 180 and then all the way up for 270 and then finish off down for 360. Make sure you're making a nice curve. Don't make a triangle like mine. Don't make a triangle like mine because it's hard for me to draw on the board. Yeah, you should have a pencil, so you should be able to do it nicely. So that is y is equal to negative 2 sine x. Yeah. Now with the period, it's slightly different. The period is slightly different. It's a little bit more technical. You have to do a bit more calculations with the period, okay? I'm looking for like something that we can do. Yeah. Okay. Sun is coming. I don't want glare in my eyes. Sun glare. Okay. So let me take a lot of this information off so that we can have a look at y is equal to sine 2x. Yeah. Okay. I'm just going to leave y is equal to sine x for now. In fact, let me take them all off. So I can make a smaller one. Because it's taking up too much space on my board. So let's make a smaller one and we'll leave it here. Black. And I'm just going to draw. This is 1. And this is 0. And this is negative 1. And this is 90, 180, 270, and 360. And this is x and this is y. We got it going up, and down, and back up. So now we want to draw y is equal to sine 2x, okay? Y is equal to sine 2x. Now the period is what is changing. We have looked at when the amplitude changes, and we've seen that results in a stretched graph, yeah? So now we should have a look at when the period changes. What happens when the period changes? I'll leave that there. Okay, period generally is equal to the regular period over the period, yeah? And I told you that for sine and cosine, the regular period is 2 pi, yeah? This is 1 pi and this is 2 pi. Oh, some people say pi over 2, 2 pi over 2, 3 pi over 2, and 4 pi over 2. Yeah, so the period is equal to the regular period over b, okay, over the new period. In this case, we want to draw the graph of y is equal to sine 2x, and our new period is 2. Yeah, b is equal to 2 here. So let's see. Using this formula, we are going to have 2 pi divided by 2. Okay, 2 pi is 360 divided by 2. This is equal to pi, or 360 divided by 2 is equal to 180. Okay, if you're doing it in radians, it will be this one. If you're doing it in degrees, it will be this one. Okay, so then let's have a look at what that will look like. Remember, I told you the period is how many degrees before the cycle repeats itself. How many degrees before that flipped S shape repeats itself, okay? How many degrees before that flipped S shape repeats itself? And here we said that it's going to be, for this one, it's going to be 180 degrees, or pi. So before we had the complete S shape for 360 degrees, but now we're going to have it for 180 degrees. Yeah, so watch. I need to draw that again. So hard to draw. Okay, I'm going to use a different color pen. I want to complete that S shape. I want to complete that flipped S by the time I get here. Okay, so I'm making sure I'm having everything, and it's here. This is 1, and this is -1. This is 0. I'm going to start the same thing again. From here, I want to make sure that yeah, and that's it. So I have 2 cycles this time. 2 cycles. Okay, I have 2 cycles instead of 1 cycle of the S shape. I have 2 cycles, one here and another one here. Okay, because it is sine 2x, not just sine x. So I'm going to have 2 of them. Okay. So that's it. Now, if this is pi over 2 here, then here, I'm going to say here is pi over 4. 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4. That's how you do it in radians. So the middle of this one, you half it, it becomes pi over 4. Remember, before it was pi over 2 or 90. Now you're getting that halfway. It's completing that cycle. It's completing that cycle in 180 degrees. All right. So make a sketch of y is equal to sine 2x for me, guys. Now, your challenge is to draw for me the graph of y is equal to 2 sine 3x. I don't know why I'm happy and laughing. So this is your practice question. You need to sketch for me and send it to me. The graph of y is equal to 2 sine 3x, okay? Remember, this is going to be the amplitude and this is going to be the period, yeah? And then you need to know how many cycles you're going to do to create sine 3x, okay? Right then. Okay, and you need to do this and show me what your markers are for degrees and radians. 1 pi over 4, and this is 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4. There's one in the middle there, 7 pi over 4, and 8 pi over 4. I'll be right back. I'm going to put, let me make that, that's the format. So you guys can see which one you have to do for me. Look here, okay? It's that one. I'm just gonna put the link to this one on Moodle now, straight away. Right, because I'm not gonna be fiddling with this after now. Copy streaming link. Okay.
Miss, I don't know how to do this.
What don't you know how to do?
3x.
Sine 3x. You got to start from here. It's going to be 2 pi over 3. Okay. 2 pi over 3. What is 360 divided by 3? See the formula? The regular period is 2 pi or 360. I put that there for you. Okay? For sine and cosine. Yeah? So when you get this one, you have to look at what the period is, the new period. This is B in our definition, in our formula, and we have to replace B with whatever B is. So it's going to be 360 divided by 3. Yeah. And then if it's in the case of this, using the radians, it's going to be 2 pi over 3. Yeah. So this is degrees. You can do all your drawing in degrees if you don't want to mess up with the radians, first of all. Then when you've done all your drawings in degrees, then you think about how you can put the radians in. But first, you have to get the drawings right. So you draw your X, your Y, and you draw your X. 360 divided by 3 is 120. So you know that you will have 120, 120, and 120 there, yeah? So it will complete that side, it will complete one of the upside down S, okay, in 120 degrees, and it will complete another one in 120 and another one in 120. So you would have how many? 1, 2, 3 cycles, yeah? So when you finish, you think about what's halfway in between these and that and fill them all in. All right, so make a start. Make a start and show me what you've done before I can tell you how to make progress.
Okay.
The rest of the class, I'm not hearing from you guys. I hope you're not planning to fail further maths. Abdullah, I haven't heard from you, okay? I need to see your graph, guys. I need to see your graph.
Miss, I sent you the graph. It's
Yeah, I
very
think
bad.
that's okay. I think I got something now in the email. Okay. Okay. So let's see. No, you don't have enough. Okay, I'm going to show you now. Right, I'm going to show you what you're doing wrong so that you can correct yourself. Where are my participants? Make host. Yes. Okay, right. I'm going to come here and I'm going to share the screen. Yes. Here. So this is your, yes, you got your amplitude. Y is equal to 2 sine 3x, okay? And what you need to do here is, I don't have my pen, so it's going to look funny. By the time you get to 120, you should have completed one cycle. So 120 is actually one cycle. Yeah? Are you seeing ring?
Yes.
By the time you get to 240, you should have completed another cycle. That's 2 cycles now. By the time you get to 360, you should have completed another cycle. That's 3 cycles, yeah? So I'm going to show you what they, yeah. So this is 1 cycle, 2 cycles, and this is your 3rd cycle. Okay, so that would then be y is equal to 2. You got your amplitude, y is equal to 2 sine 3x. Okay, so do that one, redo that one, rub them out and do it properly and then send it to me again. Then I will show you how to put the numbers in between, yeah? How to get the numbers in between. Stop sharing. Make myself the host again. No, make host. Yes. So guys, I'm not getting any work from you today. So don't blame me. Don't keep me when you fail your exam or when you get 40%. You come and keep me for 6 hours talking about how you could have got 70% or 80%. Okay. So let's have a look. Share screen. Whiteboard. Share. Yeah, can you see mine? Can you see that I have 3 cycles? 1, 2, 3.
Yes.
3. Yeah. So that's what you should have on your graph. And this graph is definitely going to be on your further maths exam. Unless I'm not going to be the one to set it, then that's a different ball game. But you're definitely getting one of these graphs in the exams. So play with it if you want to. Okay. Let me check my maths and see whether they have anything that will make it easier for you guys to understand. Sketch graphs. Trigonometric graphs. Trigonometric.
I sent you the graph.
Okay. Right, I'm going to have a look. Yeah, that's much better. That's much better. Well done. So let me do it on the board now for you so that you can see it and you can get practice how to do it, okay? So you need to know how to do y is equal to sine x, y is equal to 2 sine x or 3 sine x, y is equal to sine 2x, y is equal to sine 3x, all of those, yeah? So I'm going to do it for you on the board now. I can't just pin these down there, so it's just all over the place all the time. Okay, so what we have is y is equal to 2 sine 3x. So we know what our amplitude is going to be. It's going to be 2. Yeah. That's too much. I need to make that smaller. Okay. Right. So we got 0. We got 0 here. We got 1 on the top, and we got -1 on the bottom there. And this is x. See how I'm doing it step by step. I'm taking my time to put all the information in. Yeah, this is x, this is y. We got all the markers I put them in. I know that it's going to be 2, so I'm probably going to change these ones to 2. Yeah. So this will be 2, and this will be -2 on the bottom. Now I've got sine 3x here. I said that this is y is equal to a sine b. Yeah. And b is the period. B is the period. And for sine and cosine, the regular period is 2 pi or 360 degrees. And when you have your b, when you've been given your b, you need to use this formula. Where's the formula? Where did I write it now? Yeah, the period. You need to use this formula to do the regular period over b. Here, b is 3. So the regular period is 2 pi, okay? 2 pi over 3, or 360 divided by 3. This is in degrees, and this is in radians. Okay, so you're going to have, this is equal to 120 degrees. Yeah, so you're going to have 120, 240, and 360. Yeah, 3 cycles. Watch. By the time you start from and create that shape, you've done the first cycle. Yeah. Now you need to start the next one, go up, come down, and you've completed the next one. And if I use different colors, it might be helpful. You go up and you come down, you've completed the third one. Yeah. And those are your 3 cycles done. Now, the thing that you're going to find confusing is writing it in radians. So this is 60. If this here is 2 pi over 3, then this must be 1 pi over 3, yeah? And this must be yeah, 3 pi over 3, which is 180 degrees, yeah? And this is going to be 4 pi over 3. I'll write that here. 5 pi over 3 and 6 pi over 3. Okay, because when you got the first one, when it was 2 pi over 3, half of that one would be 1 pi over 3. Yeah, so but you pick up your marks as you go along. Yeah, if you know how to do the degrees, put the degrees in 60, 120, 180, 240. Add on 90 to that one is what? 3 watts. +60 +60 +60 +60. Oh, this is 300. Yeah, now we got it right. So it's all done. Yeah. Oh, so cool. So write what I draw my sketch completely. Make sure that you can do it perfectly. Yeah, make sure that you can do it perfectly and send it to me. I'm very cold. I don't know what's happening in this country. The cold refuses to go away. Let me get something warm for my feet and my legs. Ooh. Put the heating on. Is it working? 21. How come it's still so cold? Oh. There's no sun. Once the sun disappears, cold appears. Okay, guys. I need to see what you've done complete. Yeah, if you can do it, do it. So far, only Rim has sent me work. Okay, you need to show me what you're doing and show me that you can do it so that I can correct you if need.
Everyone is sleeping.
I know, yeah, they are sleeping. They will sleep on the exam day. They'll sleep on the exam day. Oh my goodness. Why do people put your course at this time of the year when you know it's clashing with your praying and fasting season? Oh, I think they have to look at that because it's clashing. Because it's the same thing every year. This year is the worst so far. The other years when students come into school, you can see everybody's tired, but they still come in. They still sit down in the class and they will be looking at you until after the lesson, and they will try what they can do and go away. However, this year has been particularly crazy. So let me see. I'm looking for trigonometric graphs on my maths for you guys. Let me see. Sine graph. If I don't see it on here, sine and cosine graphs. Let's have a look. Okay. You share. At least if I take you guys through this, it's going to be on your it's going to be on YouTube, and you can always go back and watch it. Right, for you guys, what is the sine of an angle? You draw a circle of radius 1 degree of 1, a circle of radius 1. Yeah. Draw a radius at any angle you wish from the x-axis. At any angle you wish from the x-axis. The sine of the angle is the height of the end of the line. In this case, if x is equal to 60 degrees, sine x is equal to 0.87. Yeah. Okay, so you guys have learned that. Right, we can't do this because, well, this is exactly what I've been explaining to you, that it goes around 360 degrees, and we translate that into coming down and going up and coming down and going up like that in quarters. This is for cosine. I haven't taught you that. What's happening? Has my internet gone off? My goodness. This weather is looking scary. Okay, it's back on. I have not taught you how to do the equations. We'll come to that. Let's look at the graph first. Y is equal to sine x. Okay, the properties of y is equal to sine x. The graph is periodic. Okay, the period is 360 degrees. I've already told you that. 2 pi in radians. Yeah, it repeats itself after every 360 degrees. The graph has a maximum value of 1 and a minimum value of -1. It has a line of symmetry there, okay? If you split it there, if you draw that line there, it's to reflect itself on both sides. 90 degrees plus 180n for all integer values. It has a rotational symmetry of order 2. Well, you guys are not ready for those ones yet. I haven't taught you cosine x, so I'm going to leave you. I'm going to leave that. Yeah, so y is equal to sine x can be transformed by translation, stretches, or reflections. Yeah, okay, so oh, this is another thing altogether. We're not doing that now. Oh, that's another thing. This is vector translation. Okay. Let's see if it's the same thing. It's the same thing. Oh, it's the same lesson. Where does the tree graph come from? Okay. Right, let me put some of them on Desmos for you guys. Stop share. I'm going to go to I think it's this one. Yeah. And I'm going to show you the behavior of all these graphs, okay? Right. So you have this here. You have this is desmos.com. Okay, it's a graph plotting tool that you can use. It's online. It's always online. If I give you a graph, you can plot it in and see what the graph looks like. Okay, so it's a good tool that you can use. Y is equal to sine x. It's going to draw that one for you in a different color. Yeah, you can see that's some 1 here and -1 here. Yeah, and although it's using 2, 4, 6 and all that, but yeah, it should be, it's completing that cycle at 6, 2 pi, yeah? It's using the radians, so you can see that the radians is written there for you to, let's see, yeah. Yeah, so that's 2 pi. So let's have a look at y is equal to 2 sine x. You can see that it has moved, it has stretched it up a little bit more, yeah? So if you want to see how all of these graphs behave, it's a good website to use, and it puts them in different colors so that you can see the one that you just plugged in. You can differentiate between the one that you plugged in and the initial one that you put in. Okay, let's have a look at y is equal to sine 2x. I'm going to remove this one. Yeah. Okay, so this is the black one is y is equal to sine x, stopping at 2 pi. But the green one now is y is equal to sine 2x. You can see it has 2 cycles coming up to 360 degrees. Yeah. Let me put y is equal to sine 3x. Yeah, I'm going to remove this one. This is the one that we just drawn. You can see that coming up to the same point here, where it's completing the 360 degrees, we've got 3 cycles there. Yeah. So if you want to, this is a good place to come to have a look at all the different graphs and how they are behaving. Right, let me take this one off, and I'm going to draw y is equal to negative sine x. That is just a reflection of the other one. Yeah, so it's just on the same thing going front and back. Yep. Another thing that I want us to have a look at is y is equal to, let me check my PowerPoint. Yeah. 4 sine x. Okay, let's have a look at sine 4x. Let's see. Yeah, let me have a look. Let me share. Let's do sine 4x with you so that you see how many cycles it will have. Sine 4x. Yeah, that's going to give you 4 cycles before you get to 360 degrees. Yeah, so, but you know how to work that out. You have to use that formula that I gave you, the regular period, which is 2 pi over 4. Yeah. So, stop share. I'm just going to be in the background now, guys. That's everything I wanted to tell you about the SIne graph and how to sketch it and how to draw it. Yeah, I hope that you can do it, because Yeah, you will either have sine or cosine or tangents in the exams. So make sure that you can do it.
Okay,
Okay.
thank you. Have a good day.
And
Bye.
you. Bye.